Hello students, today we are covering up the last part of the chemical reactions and chemical equations. That is the fifth type of the chemical reaction called oxidation and reduction reactions. Oxidation and reduction reactions are also called redox reactions. Actually, this word redox is taken from RED, reduction, and OX is taken from oxidation. Oxidation and reduction reactions are also known as redox reactions. Now, what is an oxidation reaction and what is a reduction reaction? Oxidation reactions addition of oxygen to a substance. If oxygen adds to a substance, this is known as oxidation. This is known as oxidation. For example, magnesium when reacts with oxygen, there is formation of magnesium oxide. Now in this reaction, oxygen adds up to magnesium and then only we get magnesium oxide. So here oxygen adds up to magnesium, so magnesium actually undergoes oxidation. In this reaction, oxidation of magnesium to magnesium oxide has taken place. Now, what is reduction? Opposite to this, removal of oxygen from a substance. If oxygen comes out from a substance, we say this is a reduction reaction, is known as reduction. Example, mercury oxide, when we heat it, it changes to mercury and oxygen gas comes out in this. So in this reaction, from mercury oxide, oxygen comes out. If oxygen comes out from this, that means mercury oxide has undergone a reduction reaction. In this reaction, reduction of mercury oxide to mercury has taken place. So these definitions of oxidation and reduction are based on addition of oxygen or removal of oxygen. But we can have the definitions on the basis of addition and removal of hydrogen also. So oxidation is also a removal of hydrogen from a substance. If hydrogen comes out from a substance, this is also known as oxidation. Example, H2S when reacts with oxygen, there is formation of sulfur and water. Sulfur and water will form in this reaction. Now what has happened in this reaction? From H2S, hydrogen has come out. So removal of hydrogen is there from H2S. That means this is undergoing oxidation. So in this reaction, oxidation of H2S to sulfur is taking place. Similarly, reduction, opposite to this, it is addition of hydrogen to a substance. If hydrogen adds up to a substance, then it is known as reduction. Example, chlorine, when reacts with hydrogen, there is formation of hydrochloric acid HCl. So what is taking place here? Hydrogen adds up to chlorine. That means here chlorine is undergoing reduction. Reduction of chlorine to, when hydrogen adds up to chlorine, it undergoes reduction and changes to HCl, to hydrochloric acid has taken place. So this is oxidation and reduction. Addition of oxygen to a substance or removal of hydrogen from a substance is oxidation. Removal of oxygen or addition of hydrogen to a substance is known as which reaction? That is the reduction reaction. After knowing what is oxidation and what is reduction reaction, now we are moving on to redox reaction. Like I told you, redox is from RED and OX. Combining RED and OX, we get a term redox. RED is taken from reduction, OX is taken from oxidation. So what is a redox reaction? Redox reaction is one in which reduction and oxidation, both these reactions occurs together. Simultaneously, these two reactions are taking place, is known as redox reaction. Next term is oxidizing and reducing agents. What are oxidizing agents and what are reducing agents? The substance reduced, the substance that has undergone a reduction reaction, is itself an oxidizing agent because that substance will oxidizes the other substances and is known as oxidizing agent. The substance that has shown reduction reaction will oxidize the other substances and it is known as an oxidizing agent. And the substance oxidized, the substance that has undergone oxidation reaction, this will reduce the other substances and is known as a reducing agent. It is a reducing agent. Now to understand oxidation, reduction, oxidizing agent and reducing agent, example is copper oxide. When reacts with carbon, it forms copper and carbon monoxide. In this reaction, from copper oxide, oxygen is coming out and it is changing to copper. Removal of oxygen means this is undergoing which reaction? Reduction reaction. Copper oxide with removal of oxygen is undergoing a reduction reaction. And to carbon, oxygen is added and it has changed to CO. Since oxygen adds up here, this is undergoing which reaction? Oxidation reaction. Now after this, to find out oxidizing agent and reducing agent is very easy. The substance that undergoes reduction, once we know this thing, this itself will always undergo, this one will always be an oxidizing agent. And substance that undergoes oxidation will always be a reducing agent. Like this we can find out oxidizing agent and reducing agents. One more example to understand this part. MnO2, manganese dioxide, when reacts with hydrochloric acid, it forms MnCl2, manganese dichloride, water and chlorine. In this reaction, we have to tell which part is oxidation reaction, which part is reduction reaction, which substance is oxidizing agent and which substance is a reducing agent. Now see, in this oxygen comes out. If oxygen is coming out, that means this will undergo reduction, and with removal of oxygen, this is changing to MnCl2. So MnO2 changing to MnCl2 is a reduction reaction. And in this, hydrogen comes out and this will change to chlorine. So HCl changing to chlorine with removal of hydrogen. Removal of hydrogen according to definition is oxidation reaction. Now, which substance is oxidizing agent and which one is reducing agent? MnO2 undergoes reduction, so this is an oxidizing agent. HCl undergoes oxidation, so this is a reducing agent. So this is about oxidation, reduction, oxidizing agent and reducing agent. Now next we have an activity. To understand this, heating of copper in air. When we heat copper in air, for this we are taking a china dish. We are keeping this china dish over a stand, tripod stand we are taking for this purpose, and we have to heat the copper with burner. So when we are heating it, copper is brown in color. Copper powder has reddish brown color, or we can say a brown color copper here. So when we heat it, what will happen? Copper reacts with oxygen on heating. With air, it reacts and forms copper oxide. This will be a reaction. Copper changes to copper oxide. Copper, like we have done, this has a brown color, reddish brown color. On heating, it will change to copper oxide, and this brown color will change to black color, because copper oxide is of which color? This is of black color. This is what happens on heating copper. Now in this reaction, to copper, oxygen is added up here and it has changed to copper oxide. That means in this reaction, copper is oxidized. It has undergone a oxidation reaction, and the substance that shows oxidation reaction will itself will be a reducing agent. Now oxygen here is reduced, so therefore oxygen is an oxidizing agent. Now after this, we have to reverse this process. And how we reverse this process? Now hydrogen we pass through this copper oxide. Hydrogen we are passing through this. So when we pass hydrogen to this, then again what will happen is we will get a brown color back here. So what happens on passing hydrogen to the copper oxide formed here? Copper oxide, when we pass hydrogen, this changes to copper and water. This reaction will take place here on heating. So now in this reaction, from copper oxide, oxygen comes out and that changes to copper. If oxygen comes out from this, that means this is undergoing a reduction reaction. That means hydrogen will undergo oxidation, because in this oxygen is added up. Oxygen will add up here and this changes to water. If This is undergoing reduction reaction. This itself will be an oxidizing agent. This undergoes oxidation, so hydrogen is a reducing agent. Now coming to the colors. When hydrogen is passed through copper oxide, which is black in color, it changes to copper, which has a brown color. So actually this has changed to copper on passing hydrogen to it. This is the reverse of this reaction. So this is an activity to understand oxidation and reduction reactions. Our next topic after this, the last topic of the chapter, effects of oxidation reactions in everyday life. Some phenomena where oxidation takes place in our everyday life. Two phenomena we have to study here. First one is corrosion. What is corrosion? It is the eating up of the metal layer by layer by the action of air, moisture or chemicals. Suppose this is a piece of metal. When it comes in contact with the air or with the moisture here in air or some chemicals, then what will happen to this metal? These things will start reacting with the metal and will start eating up this metal layer by layer. This is called corrosion. Some of the examples of corrosion are tarnishing of silver, tarnishing of silver, rusting of iron, and the green coating on the copper. These are examples of corrosion. Now first we are taking is the corrosion of copper. Corrosion of copper. Why this green color comes on the copper? Copper particles, they develop a coating of green color, and that green color that comes on a copper, that is actually because of the on surface a green color will form somewhere. This green coating formed here is actually copper carbonate. So when copper comes in contact with air, it reacts with the carbon dioxide of air and the top layer will start changing to the copper carbonate. Copper carbonate is of green color. This is of green color. That is why there is a coating of green color on copper things. And this will happen when copper is exposed to humid atmosphere. Next is corrosion of silver, which is also called tarnishing of silver. Corrosion of silver is also called tarnishing of silver. Silver things, they lose their shine and they will be of black color now. This is due to their reaction with hydrogen sulfide present in air nowadays as pollutant. And because of this reaction, silver changes to silver sulfide. And silver sulfide is of which color? Black color. This is silver, shiny silver color. But when it comes in contact with air, it reacts with the H2S present in air and changes to silver sulfide, which is of black color. This is silver sulfide. And this is also called tarnishing of silver. Now, third example of corrosion is corrosion of iron, which is called rusting of iron. Corrosion of iron, that is also called rusting. So when iron articles, they come in contact with the moist air. Iron article when comes in contact with the moist air, this reddish brown flaky layer on the surface. This is a reddish brown color flaky layer formed on a surface. The reddish brown flaky powder formed is actually hydrated ferric oxide. This reddish brown layer formed on iron article is Fe2O3.XH2O, hydrated ferric oxide. This is the formula of rust. This is also called rust. So formula of rust is Fe2O3.X water. Now, how we can prevent this corrosion? How corrosion can be prevented? Prevention of corrosion. Corrosion mostly takes place when articles they come in contact with moist air, especially air. So we have to keep these articles away from air, away from oxygen. So on the surface of the metal, we can have a coating of paint or varnish. By coating the metal surface with paint or varnish, so that layer will keep the metal away from oxygen. Second method is in machines, the movable parts of machine, what we apply to these is grease or oil we can apply so that they are away from the oxygen, and the machine parts they can move easily. The lubrication will be there and there will not be any rust formation. Third method is corrosion of metals can also be prevented by coating the metal. We can coat the metal with some non-corrosive metal. On the surface of this we can have a coating of some metal which will not undergo corrosion, non-corrosive metals. Now example of these non-corrosive metals is, if this is copper, then on the surface of this non-corrosive metal, tin is applied. Next is, if it is metal oxide, it can be electroplated with the noble metals like silver or gold can be plated here. Corrosion of some metals can be prevented by converting them to their alloys. Like iron gets rusted, so it is changed to stainless steel. Stainless steel does not undergo corrosion. Stainless steel we can have from the iron. Next method is rusting of iron can also be prevented. On iron we can have a covering of zinc. Zinc covering can be here on this. This method of covering iron with zinc is called galvanization. Now zinc is more reactive than iron, so zinc will undergo this oxidation and will protect the iron here. These are some methods by which corrosion can be prevented. So this is about corrosion. After corrosion, the second phenomenon that takes place in our everyday life of oxidation is rancidity. What is rancidity? When food which contains fat and oil that is exposed to air for a long time, it will keep the food containing fat and oil outside, then it becomes rancid. That food will become rancid. Rancid means there is a bad smell and bad taste is there in that food. Because that food has undergone oxidation, it has reacted with oxygen. And because of that reaction, the food will have a bad smell and bad taste, and this phenomenon is known as rancidity. Prevention of rancidity. How we can preserve the food for a longer time. How we can prevent this attack of oxygen on the food. To prevent this rancidity, To the food containing fat and oil, we can add BHT and BHA. These are antioxidants. These are antioxidants. They will not let oxygen to attack the food. Full form of BHT is butylated hydroxy toluene, and full form of BHA is butylated hydroxy anisole. So these antioxidants can be added to the food. Next is to the food, packed foods like the chips and all that, nitrogen gas is added to these chips packets. To the packed foods, nitrogen gas can be added. Nitrogen is an inert gas, so this will not attack the food packed inside the packets. Next is we can store the food at a low temperature. At low temperature, the reaction slows down. And for that, we use refrigerator. So if we keep the food at low temperature in refrigerator, we can keep it for a longer time. This retards rancidity. We can store the food materials in airtight containers. In airtight containers, the oxygen cannot enter inside, and hence we can keep the food for a longer time. And keep the food away from sunlight, because sunlight has heat in it, high temperature will be there, and this rancidity will be fast. So these are some methods by which we can prevent the rancidity and we can preserve our food for a longer time. So this is the last topic of this chapter, chemical reactions.